all, we will revise what we studied in the last class. Then we'll move to the topics of the day. All right. Okay. कल हमने क्या क्या किया था? हाँ, तो yesterday I informed you about the shape of the earth, oblate, spheroid and geoid shape. I hope ये याद रहेगा. This thing we talked about. Then we started with the interior of the earth. Yes. So interior of the earth. So let's quickly revise. So what are the sources of the information? Interior of the earth. Direct sources, surface rocks, mining rocks, drilling projects. We know we have, as humans, we have gone to the depth of 2 to 3 kilometer gold mines in South Africa. And regarding mining or drilling projects, maximum it has been to Kola Peninsula. Right? It is between, or you can say north of Russia in the Arctic region. Right? Okay. Then another direct sources is volcanic eruption. To keep this thing in mind, in direct sources, we analyze the properties of different matters, so that we got to know that as we move from surface towards the core, temperature, pressure, density increases. Secondly, sorry, meteors. Since meteor has been formed through the same process as our planet Earth has been formed, so through indirect analysis of meteor, we found the information about the interior of the Earth. In seismic activity, they show three kind of properties. First is reflection and refraction. When there is a change in density of the medium, the ray of light, or you can say waves, direction in the movement of the waves changes. Either they refract, or you can, this is how, if they're moving, this is straight line, either they move towards the normal or away from the normal, or they get reflected. This is the basic. Then their speed depends on the density. More the density, more the speed. And thirdly, third property which helps us, medium, through which medium they passes. P waves passes through all three mediums. S wave passes through only solid medium. All right. Then gravitational anomaly, it helps us to understand how mass distribution inside the Earth is taking place. Then magnetic field anomaly, magnetic field should be same at all places of the Earth, but we find different magnetic value at different points. All right. Then sources of Earth inside internal interior of the Earth, we have three sources: radioactive decay, primordial heat, or you can also call it as residual heat. Sometimes this term is used, residual heat. Residual heat, primordial heat are same. Radioactive decay, nuclear reaction is taking place, mainly fission only. Fusion is found in sun and stars. All right. Then tidal friction based energy. So these are three sources. All right. Then we talk about earthquake. Earthquake is what? Simply shaking of the earth. So point where earthquake is or energy is released is known as hypocenter or focus, and surface point at the surface, nearest point at the surface of the earth, it is known as epicenter. So two type of waves are released: P wave and S wave. P waves are what? Longitudinal waves. If this is the direction of the movement of energy, so even rock particles will move in the this direction only, same direction. So they would be stretching and squeezing. In case of S wave, this is direction of the movement of energy, and there is a movement of particles in the perpendicular direction. So it is a transverse waves. All right. And P waves are first to arrive. They travel to all three mediums, solid, liquid, gas, and their speed depends on the medium. Secondary waves, S waves, they travel only through solid. Then when these both the waves, body waves, reach the surface of the earth, so they create new set of waves which are known as surface waves. It has two types, Love and Rayleigh, right? And it is also transverse wave, right? And it has long wavelength, low frequency, and they are last to arrive. So first P waves arrive, secondary waves, then surface waves. And surface waves are more destructive. Why? Because at the surface only we have infrastructure built. So if surface waves will cause maximum damage to this infrastructure, so that's why they are more destructive. And also these are transverse waves. All right. Then how they help us understand the interior of the earth, we just discussed different arrival times, because speed varies with the change in density of the medium, refraction, and they're getting different shadow zones. Shadow zones, but we have to remember S waves have more shadow zone. It is from 143 to 143, whereas P wave has only 140 to 105. Just keep this thing in mind. shadow zones. Sorry. Then, also we find the seismic waves. Their speed varies. At what point discontinuities? Discontinuities in the interior of the Earth. Those are those areas where there is sudden change in density. So I told you about their CMRGL between uh, crust, continental crust and oceanic crust. There is Conrad, crust and mantle. There is Moravich. Then upper mantle and lower mantle. There is rapidity. Then mantle and outer core, or you can say core. There is Gutenberg, and then lastly outer core and inner core. There is Lehmann. These are the discontinuities. Okay, this you need to remember. Then types of earthquakes, or you can say what are the causes of the earthquakes: movement of plates, volcanic activity, collapse of, you can say, mining areas, explosion activities, and reservoir induced. Reservoir induced example I gave Koina earthquake in India, 1967. This is a famous example. Effects. UPSC had asked question if you have to detect how earthquake is taking place, radon gas. Even recently, there was a lot of in news like regarding Turkey. Actually, uh, in China in 1970s, they were able to predict the earthquake. How? Because just before the earthquake taking place, there is first of all release of radon gas. First of all. Secondly, uh, behavior of animals. It gets changed because animals are able to detect the waves first. So behavior of animals, it changes. So these are the two ways through which we humans can predict. But still, their behavior is only just 2 to 3 minutes before the earthquake taking place. So we don't get that much of time to prepare for ourselves. Just keep it this. Alright. What are the other effects? River course getting changed. Right, route of the river getting changed because of Assam earthquake. Ground shaking, landslides, avalanches, floods, fires, infrastructural damage, tsunami, soil liquefaction, loss of life, and land upliftment. Basic example was Alaband fault. Right? Tsunami example, Indian tsunami, which took place in 2004. I hope these examples already done. Alright. Then, if order of destructive, surface waves are more destructive than S wave, then P wave. Keep this in mind. Alright. Then, what we study about the structure of the Earth? So, interior of the Earth, we classify them into two types: mechanical classification and chemical classification. In case of mechanical classification, what we have lithosphere, which consists of what? Crust, and upper part of mantle. Then below it, we have asthenosphere, which is semi-solid state, and it is the area over which lithosphere plates move. So asthenosphere is associated with plate tectonics. Keep in mind. All right. And also it is a source of magma. So two things: source of magma. Secondly, it is associated with the plate tectonics because plates are moving over which area? Semi-solid state, which is asthenosphere. And plates consist of what? Lithosphere. Lithosphere plates is divided into various parts, which is known as uh, plates. Then below it, there is mesospheric, which is the lower part of mantle. Then outer core, inner core. Right? Okay, so let's then chemically we divided it into three types: crust, mantle, core. Mantle, you can say lower and upper mantle. Core, you can say outer and inner core for the subdivision. All right. So now crust. Crust is of two types. If we talk about, this is crust, continental crust and oceanic crust. So continental crust thickness is more, if you can look at, and continental oceanic crust thickness is less. First of all, when it comes to density, this is core. So density would be more in case of oceanic crust because gravity force would be pulling heavier material. Density deposition took place. Heavier material deposited near the core areas, lighter away from the core. So continental crust is away from the core, so you can say it has less density. Oceanic crust has more density. This is one of the, this is a basic logic, you can say. But oceanic crust has more density. Continental crust, example, oceanic crust ka basalt, continental crust ka granite rocks. But yes, in case of our Deccan Plateau, it is made up of what? Basaltic rocks, not granite. Agar in spite of it being in continental area, keep this thing in mind. All right. In the case of continental, you have felsic rocks. They are lighter element rocks, and they have elements like sodium, potassium, aluminum, silicate. So Sial rocks हम बोलते हैं. Silicon aluminum dominates. In case of oceanic mafic, they are denser, darker colors, and over Sima dominates. That is magnesium dominates. In case of continental, aluminum dominates. In case of oceanics, magnesium. All right. Then crust. If you find out what all elements are found in the order, so it has maximum oxygen content, then silicon, aluminum, iron. All right. So this is all about in this crust part. Then mantle. In case of mantle, what we find, it is this crust is separated from mantle by Mohorovich discontinuity, and mantle consists of what it compose 83% of Earth volume and 67% of Earth mass. All right. And what all minerals are from? Seawater minerals, silicon and magnesium dominates. Silicate rocks. So in case of metal, upper part, some part overlaps with the lithosphere, then it has asthenosphere, and then lower part of mantle. Right. All right. And this is a region where convective ideal circulation, convection current will take place. We'll see it in the Arthur Holmes story. All right. Then core. In case of core, we have Niffe layer. So Niffe layer basically it consists of iron and nickel. Nickel ka Ni, iron ka Fe. So Niffe layer. All right. Maximum density 13 gram per centimeter cube. All right. In the its inner core is solid, but outer core is liquid. So it has liquid iron and nickel. Now, what is happening in case of outer? There is a movement of these particles. Now, why movement is possible? Because of Coriolis force, and when they move, they create convection current. Now, because of this convection current, what is happening? Formation of magnetic field. So this creates the magnetic field around the Earth. So we find magnetic field around the Earth. Now, magnetic field around the Earth. So now various phenomena is taking place. Solar winds come, magnetic field interacts. So when there's a trapping of charged particles, it creates Van Allen radiation belt. Then this sphere surrounding the Earth, magnetic field, it is known as magnetosphere. And various phenomena is forming because of these. When there is increased intensity of the solar winds, that is during geomagnetic storms, due to magnetic anomalies in the sun, intensity of the solar winds increases. So this creates a lot of problem because this is lower Earth orbits surrounding the Earth. Over here, satellites are found, spacecraft, astronauts, so everything gets affected. Even on Earth, what is happening? Earth के upper atmosphere में solar winds are interacting in the ionosphere. Ionosphere is responsible for what? Radio wave communication, and also there's a presence of atomic gas, oxygen and all. So they interact with atomic gas, they form aurora phenomena, and they affect the radio wave communication. But when solar winds reach on the surface of the Earth, they may affect the movement of animals, because some animals rely on what? Magnetic field for movement. Also, magnetic field, or you can say weakening of the magnetic field, may affect the our transmission of electricity. It may cause blackouts. Keep this thing in mind. And we have geographical axis, magnetic axis. So magnetic axis and geographical axis, the angle between them is 11 to 11.5 degree, and magnetic axis is moving towards west. Yeah, एक चीज ध्यान रखना, मैंने आपको थोड़ा सा कल उल्टा बता दिया था. मैंने कल आपको बताया था कनाडा से it is moving towards Siberia region. Sorry, Siberia से Canada region. Rather, it is happening like this. This is Canada region. This is Siberia. Over here also, if you look at on the west part of Canada, there is Siberia. So magnetic axis कैसे move कर रहा है from Canada region towards the Siberia region. This is how it is moving. तो ये ध्यान रखना. कल मैंने आपको ऐसे बताया था साइबेरिया से कनाडा, सॉरी वो गलत था, कनाडा से साइबेरिया, सॉरी हाँ ऐसे मूव कर रहा है. दिस इज हाउ इट इज मूविंग. एक ये ध्यान रखना. एंड दिस मैग्नेटिक एक्सिस में रिवर्सल पॉसिबल है, राइट. अभी आपको ऐसे दिख रहा है साउथ पोल नॉर्थ पोल, फ्यूचर में क्या होगा? नॉर्थ पोल साउथ पोल. ऑलराइट, ये आपको ध्यान रखना है. किस स्पीड से मूव कर रहा है? 40 किलोमीटर पर ईयर से. ऑलराइट, This is we all talk. हाँ, then magnetic field अगर हम planets में comparison, ये बहुत important है because अब world over क्या है, we are exploring the planets. Why? Because resources are ending. ये देखो transition देखो, पहले land resources थे, they are ending, they have already depleted, so now we are moving towards the water resources. So now concept has emerged, blue economy. Further, we know these resources are limited, we are moving towards the outer planets, towards planets in the space for resources purpose. It's just we humans are greedy and we want to exploit the resources for it. So magnetic field, Mars and Venus have zero magnetic field. Jupiter has the largest. Saturn, Uranus, Neptune, they have more than Earth. This is what you need to know about. And Mercury has little bit of magnetic field, but it is less than Earth's. All right. So this is all we studied yesterday. All right. Then also we studied about. Yeah, I hope you must have did the analysis. तो एक जो क्वेश्चन आया था वो देख लेते हैं कि राजस्थान कि नॉर्दर्न राजस्थान से लैटिट्यूड पास कर रहा है तो किस कंट्री स्टेट से पास करता है, अरुणाचल से, सिक्किम से, राइट। मिडिल राजस्थान से पास कर रहा है, कौन सी नॉर्थ ईस्ट से पास कर रही है, असम, नागालैंड, इवन मेघालय। लोअर राजस्थान से पास कर रहा है किसके से, त्रिपुरा, मणिपुर, इवन और नीचे जाए तो हम त्रिपुरा, मिजोरम से ही पास करते हैं। दिस इज ऑल वी स्टडीड ऑफ, राइट। देन जो एक बार यूपीएससी ने पूछा हुआ है लॉन्जिट्यूड, एक लॉन्जिट्यूड है दिल्ली से, तो देखिए अगर हम बेंगलुरु भी उसके पास है और उसी के लॉन्ग दिल्ली भी है, ऑलराइट, तो ये ध्यान रखो। सो दे lie along the similar kind of longitude only. So this has been the previous question. तो ये मैप को just observe करना है आपने, right? And Indian Standard Time 82.5 degree longitude. ये basics ध्यान रखना, alright? Okay, so now let's start with the topic. Alright. अर्थक्वेक देखो, ये जो अभी टॉपिक्स हमने किए इस पे यूपीएससी ने क्वेश्चन पूछा नहीं है, because these topics are UPSC's main topic. But yes, last year they had asked question on this, the geomagnetic storms. So what are its impact? So they were almost 6-7 points. It was direct, easy question. So although you now last year during preparation you must have thought ki there's no need to study about this, but we have to study about each and every, because UPSC can ask anything. Right? Although some topics it may not have touched in the previous years, but UPSC will ask you about anything. All right. So now let's continue. Let's start with the topic of the day. All right. So next topic जो हमारा है volcano. ये UPSC का favorite topic है, but not in prelims for mains. But still we have to cover. So let's cover basics of the volcano. If you'll see in the mains topic, UPSC had asked question on volcanoes very frequently. In the last 2-3 years, so it is asking question on it. So if UPSC can ask question in mains, then it can ask in prelims also. All right. So let's start. So now in simple terms, what is volcano? Volcano is nothing. It is a cone-shaped mountains which is connected to magma chamber. Magma chamber is what? It consists of magma. What is magma? Simply molten rocks. So we know temperature increases as we move inside the earth. So whatever rocks are present, because of high temperature, they melt. And those melted rocks or molten rocks are known as magma. So these magma chamber. Now what is happening? Rocks have solid rocks. They have high density. If they melt, what would happen? The density would decrease. Now due to density differentiation, now gravity force is acting. if gravity force is acting from the core region. It will pull heavier material towards itself, and lighter material would be at far distance. So if density is decreasing, the molten rock, or you can say molten magma, its density would be less. So what would happen? Heavier material will sink, that melted rock will start rising upwards. But you can say it rises because of buoyant force. BYOYA and force. Or you can say because of density differentiation, its density decreases, and so magma will start rising upwards. So what is happening? Magma chamber, this is surface. So magma will start rising, and as it rises, it will rise and it will explode. Oh, sorry, erupt, reaching the surface of the earth. When it erupts, what would happen? This is surface. Magma rises. Again, temperature would be less at the surface. It will start cooling down. It will cool down. It will form rocks. Then again, new set of magma rises. New set of rocks. So ultimately, it will lead to formation of mountains. So these conical shaped mountains are known as volcano, in which their center is connected. At center, it has vent, which is connected to magma chamber. Right? This is simple definition of volcano. And volcanism is what? Rising of magma due to density differentiation to the surface of the earth and eruption of the magma. Simple. This is volcanism. I hope now you will remember this definition of volcanism. Okay.
Hello, sir.
Yes.
Sorry to interrupt you. Sir, when you are writing with S pen, some noise coming, sir.
Sorry.
Sir, when you are writing with S pen, some noise coming.
Okay. Okay.
S pen noise, sir. I think, sir.
Uh, 1 second. Is noise coming now also while writing?
No, sir, not now.
Okay. It was basically, I guess, external noise issue. All right. I have closed the windows also. So what is happening basically? I hope you have got the basic idea of volcano. All right. So basically, what involves in case of volcano, differential radioactivity. Basically, how heat is released. Heat is being released via radioactivity elements that is taking place. That nuclear reactions. Heat is released, and this causes melting of rocks. So this will create what? Temperature gradient, convection current, the rising of mantle. Is basically what is. It is also known as convection current. Now, as we'll see in the future topics, if that magma is rising, what it will cause? It will cause movement of the plates. So now what may happen? Plates may move towards each other. If they're moving towards each other, they will cause convergent boundary. If they're moving away, they will cause divergent. So this is what it's written. All right. So next thing that rises, because this is what UPSC had asked last year also, types of lava. So there are two types of lava. You need to keep in mind. Lava, that magma that is rising. Andesitic. Then we have basaltic. So in case of andesitic, of different scale. Andesitic are basically acidic lava. Basaltic are ones basic lava. Now in case of acidic and basic, what is happening in case of andesitic? You have high silica content. Right? Keep this in mind. They have high silica content. Alright. When it comes to, sorry, andesitic, basaltic. They have high silica content. In case of basaltic, you have low silica. So they are acidic lava, they are basic lava. So since they have high silica, so that content in the magma, they are highly packed, closely packed. So they are like viscous. It's like jam. You are keeping jam and water on the same piece of table. So now what would happen? Water would be having more fluidity as compared to jam. So when liquid is able to move freely, so it is having the property of low viscosity. But if it is not able to move freely or low fluidity, it is viscous. So basic has low viscous. All right, keep this thing in mind. Then these are light colored. These are dark colored. Best example, basaltic rocks we find in Deccan Plateau. Because of basaltic rocks, there is a creation of what? Genesis of black soil. That is dark color. So you can use this logic. All right. Keep this thing in mind. Okay. So andesitic, acidic, they are viscous, so they are slow moving. So they rapidly solidify. All right. Now, in case of andesitic, what you need to keep in mind. Now see, suppose this is magma. Oh, sorry, volcano. Now, if magma is rising, now we know it is slow moving. So what would happen? Some magma will start depositing. In future also it will deposit. So what will happen? Due to solidification, and so what will happen? They will block the future movement of magma. So ultimately, if new magma has to rise, they will have to break that plugging of the plug rate हुआ है vent में. They will have to break. So ultimately, this leads to explosive eruptions. Because if you have to escape to the surface, magma has to escape. तो वो कैसे escape होएगा? Only by breaking of the that plug which has been created by the solidification of the previous magma. Right? So basically, what is happening? Rapid solidifying of lava obstructs flow of outpouring lava. Right? So this results into explosive, or you can say explosive. I hope you're clear. This is found in case of andesitic lava. ये ध्यान रखना. Right? In case of basaltic, we don't find such issues because it is highly fluid, so it is able to move up to the surface of the earth and spreads on the surface of the earth. All right. So it creates thin sheets because it is rising, and it will be able to move. So it will be able to move to large areas. So there won't be any, even if new lava comes, it will move to reduced surface area. So there's a thin deposition of lava. But in case of andesitic, what is happening? Lava comes, one layer of lava deposits. Another would come, it will deposit on this above that previous layer only. So this leads to thickness of the deposition. So andesitic lava, thick deposition, basaltic, thin sheets. All right. And they are mainly found along the divergent boundaries. Just keep this in mind. I hope you're clear. All right. So types of lava: andesitic, basaltic. Andesitic are acidic, basaltic are basic. Andesitic have high silica, basaltic has low silica. Andesitic are viscous, light colored. Basaltic are low viscous, dark colored. Just इतना ही पता होना चाहिए आपको. Okay. Then volcanic landforms. Now two type of landforms are formed. Inclusive, exclusive. Inclusive is also known as plutonic landforms. All right. Now see. This is magma chamber. This is volcano. This is wind. Now suppose magma is rising. Now there are two possibilities. If magma is rising and if temperature falls down, so it is possibility that magma solidifies in this region itself, interior, or what may happen, magma may rise, erupts, and it may solidify outside. So there are two possibilities: either interior cooling and solidification of magma takes place, or in the outer region, or you can say above the surface. This is surface region. This is interior of the earth, right? So based on the location where solidification of magma is taking place, we classify landform formation, intrusive plutonic or extrusive landforms. So inside the earth, two types of deposition can take place. Different shapes would be formed, but you can say different landform. You just need to see, UPSC will ask simply, this is a particular landform, what kind of shape it represents. All right. So what you need to remember, first of all, it has large batholith. It is an irregular shaped magma solidified. Large irregular shaped magma at the interior of the earth. All right. It doesn't have any kind of shape. It could be anything. Batholith, just keep in mind, if magma is rising and it deposits in the form of vertical wall. So they are known as dikes. This is vertical wall. Sometimes what may happen, magma starts moving in the horizontal direction between the cracks of the rocks, and it may deposit in the form of horizontal shape. So they are known as sheet and sill. So dikes are the vertical shape, vertical wall type. Sheets are the horizontal shape. Or sometimes what may happen, they may deposit in the form of depression. Now this is looking like a saucer, chai ka pyala, right? So they are known as lapolith, saucer shape. They may deposit in the form of dome also, dome shape. So they are known as lapolith, dome shape. Lastly, along the, if in some regions you may find folded rocks in the folded mountains. Right? So along the crest and trough, I hope you know crest part of folded regions. They are known as antisyncline, anticline you can say, and this trough part of this folded region they are known as syncline. So along the anticline and syncline region, so you find waves of deposition is forming. So these are known as facolic. Basically wave shaped deposition along the anticline and syncline region of folded bed, folded mountains which we all know. So I hope you're clear. These, you just have to remember these shapes. Dikes are vertical wall, sheet cell horizontal shape, horizontal sheet you can say, right? Then lapolith saucer shape, facolic dome shape, and lapolith locolith, and facolic. Facolic is wave shape deposition. Just keep this thing in mind. Right? So patholith के large body appears on the surface after denudation. Large body है, this is large body, right? And on deposition, if everything above it, rocks present above it, are gets eroded. So they may appear as the dome shape. The best example इसका क्या है? Example कर्नाटका dome. कर्नाटका में हमें ऐसी एक डोम मिली है, right? Rocks have been formed. Lacolith, dome shape. Lacolith, saucer shape. Facolith के crest of anticline, syncline. Cells horizontal. Now cells and sheets में different के sheets thinner होती है, cells thicker होती है. That's it. They all are sheets. Sheet के thin, cell के thick. Just keep this thing in mind. है दोनों horizontal shape भी. Dikes vertical. Right? Sometimes what may happen, magma is rising, but it may start solidifying, so it may choke the vents. So those are known as volcanic plugs. So viscous lava solidified in the vent. Right? Example, Shiprock found in New Mexico, Devil Star found in Wyoming, China. These are the examples. Even if you don't remember these examples, you can leave it. Just remember these things. So they are cooling where? Cooling inside the earth. All right. Now comes extrusive blocks. So extrusive. All right. So how to approach this extrusive landforms? See, first of all, on the basis of lava itself, whether it is viscous lava or less viscous lava. If you have viscous lava, that means lava is not able to move to far distance. So it has low fluidity. So this results in the formation of composite type of volcano. Extrusive means basically landforms formed above the surface of the earth. Right? So composite type of volcano, what all we can say about it has andesitic lava, basically acidic, again viscous, right? So how it will look? Magma is rising. Now what will happen? First layer of magma is deposited. Again eruption takes place. Second layer of magma. Again eruption takes place. Third layer of magma. So what is happening? Layers of magma is getting deposited. First layer, second layer, third layer. So stratified layers are formed. Right? They are also known as stratovolcanoes. ये ध्यान रखना. इसके examples, and usually these are what? These are highest, जो high mountains हमें मिलते हैं वो यही होते हैं highest mountains. Example इसके जो लिखने हैं आपको. Mount Stromboli, Mediterranean Sea में. Then Mount, वैसे याद नहीं देंगे examples, you can avoid also. Vesuvius. You can also put, otherwise leave it. All right. Then another type of volcano is shield type of volcano. तो इसमें क्या होगा? Basically low viscous. So what would happen if magma is erupting? What would happen? Magma would be able to stay at one location. It would be flowing. So this results into formation of low height volcanoes. यहाँ पे क्या? High height volcanoes. यहाँ पे क्या? Low height. Because it has low viscous lava, so it would be whatever lava is erupting, it will flow to larger distance. So there would be accumulation of one lava over the other. So you have low height volcano. Right? So it has mainly what? Basaltic lava, which is very fluid, right? Okay. These are not steep, and best example are Hawaiian volcano. And these would be less explosive, but yes, composite type of volcano would be more explosive because we know it can solidify and block the vent of the volcanoes. All right, clear? All right. Then sometimes what may happen, we have another type of fissure type of landforms or eruptions. In this, what is happening? There is silent eruption. This is land, magma is rising. So there won't be rise of magma to upper heights. Rather, it will just slowly rise, it will spread. So this is silent type of. So this leads to formation of plateaus, plains. Best example of plateau is Deccan Plateau, right? So you can remember a few examples of the world. In India, we have Deccan Trap, right? In again, this Russia region, Siberian traps, we say it's basically plateau only traps, right? Then in USA, we have Snake Basin, right? Iceland, Icelandic Shield, and also lastly Canadian Shield. So these are the few example of these. You can say fissure type of eruption. And यहाँ पे कौन से material आता है? Basically release of basalt volcano, right? So even if UPSC जैसे UPSC ने पहले पूछा डेक्कन ट्रैप में कौन से रॉक्स मिलते हैं basalt. So future में पूछ सकता है Siberian trap, Canadian Shield, Snake Basin, Icelandic Shield. What type of volcanic rocks are formed? Basaltic rocks. Just keep this in mind, right? So basically इसको crux में लिखना है. So basically in this magma escapes to Earth's surface slowly in intervals, right? And spreads over a vast area, large area, and creates flat surface. Simple, right? Fissure type of volcano. I hope it's clear. किसी को कोई डाउट होगा तो चलो I'll ask you in a while. All right. Then another type of volcano is जो हमें लैंडफॉर्म देखने को मिलता है crater. There are 2-3 terms जो हमें clear होनी चाहिए. Crater, caldera, cinder. These are the 3 type of cones जो usually हमें problem create करती है. Usually हमें exact definition ही पता होती है इनमें difference क्या है इन तीनों में. So let's have a look at crater, caldera and cinder. इनमें clarity बहुत जरूरी है. Because minor difference ही है और ये तीनों दिखते एक जैसे ही है. So what is need of a minor difference? All right. So what is crater? It is nothing. It's just a bowl shape or depression shape. So it will look like this. See, earlier it is supposed to be like this, full mountain, but what is happening? It appears like depression shape. where center is connected with the magma chamber. So basically it looks like inverted cone shape. Inverted cone shape. Right? Vent is present. यहाँ से magma आ रहा है. यहाँ से magma आ रहा है, right? Vent. It is appearing like inverted cone shape. Right? Or you can say depression shape. Depression is what gap create किया हुआ है हमने hollow shape. So this is what simple crater. Right? Sometimes what may happen, water may accumulate in this region. Water may accumulate and it will lead to formation of what? Crater lakes. Crater lakes may form if water gets accumulated in this region, in crater. This is simple crater. What you need to know about. Alright. Then another, what you need to know about cinder cones. Alright. So see, in this of cinder cones, it looks like crater only, where there's inverted cone only, inverted cone. Right? Inverted cone is present, connected to magma chamber, vent is there. But only difference is that in case of this cinder cones, there is presence of rock fragments. So broken rock pieces are present over here. Right? So along the vents we find rock fragments. But in case of crater, you may or may not found. But in case of cinder cones, what is happening? It is an oval shape, or you can say inverted cone shape. Right? There is a better term would be oval shape. Right? Oval shaped, inverted cone shape. But inside the this volcano, there's presence of huge pieces of rocks. So these rock fragments are present and they block the movement of the magma as they rise towards the surface of the earth. And this leads to formation of explosive volcanism. So this is cinder cone. Okay. Then, sorry. क्रेटर लेक का एग्जांपल लिख लेना. बेस्ट एग्जांपल लोनार लेक जो इंडिया में है. और लास्ट ईयर इट वाज लास्ट ईयर देयर वाज अ pink color water found in this region. It was due to presence of algae only. And where it is located? In Maharashtra, in India. Right? But keep in mind, this Lonar Lake was not formed due to crater lake or because of volcanic activity. That crater depression was formed due to meteor. Keep this in mind. All right. Lastly, we have caldera. Now, again, caldera. Some people say it is just a large size cinder cones, right? But how caldera is formed? This is also quite different aspect. Suppose this is volcanic activity. Volcano connected by vent, magma chamber, and this is what volcanic core. So now what is happening? Now since this is magma chamber, it is a source of molten magma. Now all the magma gets empty. Well, all the magma escapes to the surface of the earth. So magma chamber gets emptied. Now since magma chamber gets emptied, what would happen? This would be completely empty. So there will be a lot of pressure from the above, and it won't be able to handle the weight of the overlying rocks. So what would happen? There would be collapse of the volcanic mountain, or you can say collapse of the region. So this whole wall, this was collapse, right? So surface collapse and it will look like this. At the center you have volcanic mountain, and from the other regions there's a gap. Gap is formed because of collapse, because this region gets collapsed beneath, right? So it will appear like there's a land mass surrounded by the hollow mass. So this is what caldera is basically. And if water gets accumulated, it leads to formation of caldera lake. So basically how caldera is formed, it is nothing when magma chamber, which is below the surface, it gets emptied after volcanic eruption. So ultimately what would happen, volcanic mountain or hills or material, whatever it is above the chamber, it will collapse into empty magma chamber, and this collapsed surface, at the surface which has collapsed, it will look like a empty space or depression. This is simple caldera. So you can write also, like if you want. So what are steps involved? Magma chamber above the surface, oh sorry, below the surface. May be emptied after volcanic eruption. So volcanic material or landform above chamber collapses into empty magma chamber, and collapsed surface appears like hollow, hollow body, right, which is known as caldera. Right, ये ध्यान रखना. So difference clear? Crater, caldera, cinder. Crater is nothing but just a depression, and there is continuous eruption of lava. Cinder is what? Depression, but presence of what? Presence of rock fragments. In case of caldera, how it is being formed? Magma chamber gets emptied, so there's a collapse of upper landforms present above the surface. So ultimately, what would happen? Center rocks would be left, but nearby rocks would all get collapsed, and they will move down. Right. So this is so example of crater lakes. You can say Lunar Lake. Another example of crater lake is Lunar Lake is formed due to impact of the meteor that depression created. Then you have Lake Toba. This is in Indonesia. And this is what? This is largest crater lake of world. Give this in your mind. Lake Toba, Indonesia. All it. This thing you need to remember. Okay. So landforms done. I hope clear to all of you. So cinder cones, we have seen composite cones. The stratovolcano, St. Helena, Mount Pinatubo, shield volcanoes, example Hawaiian, caldera depression formed by collapse of most explosive volcano. This leads to formation of caldera lakes. Flood basalt province, we have seen example Snake Plateau, Colombia, Maharashtra Plateau. That Columbia Plateau is Snake Plateau only in USA. Metoceanic ridges formed along the ocean surface. So Atlantic, Pacific, Indian Ocean ridges, right? All right. Then most important, UPSC had asked question in the mains on the hotspot volcanism. So now what is hotspot volcanism? Let's have a look at it. Now see, hotspot volcanism, or we also say it in other terms, mantle plumes. Because UPSC had asked question in the mains, what do you mean by mantle plumes? All right. Suppose this is core, this is mantle, and this is crust, or you can say plate. So in simple terms, what are mantle plumes? See, first of all, you need to aware of that molten magma. They are originated at two areas. One is core mantle boundary. Second is that asthenosphere region. So these are the two areas from where molten magma originates inside the earth. Right? Okay. So in case of mantle plume, what is happening at the core mantle boundary? Because core mantle boundary, there's a huge temperature. Rocks are present. So lower rocks of the lower mantle, they will melt. These are rocks of the lower mantle. And the presence of higher temperature, what would happen? These molten magma will start rising. And as they will rise, what will happen? They will hit the crust region. All right. Now suppose crust is not present, it's just presence of plates only. All right. So along the mantle region, these are the fixed spots from where these convection currents or mantle plumes are rising. So now what is happening? This is plate, this interior of the earth. So core, mantle, rise of. So at this particular position, position A, is a rise of magma. So now what would happen? As plate will start moving towards it. As plates will move, what would happen? Mantle core boundary. At this position, magma will come out. It will lead to formation of mountains. First mountain. Again, plate will move further. As plate will move further, what will happen? These are the older mountains. New magma is rising. It will lead to formation of new set of mountains. So as plate will move, it will lead to formation of chains of mountains. So what is happening? See, hotspots are the fixed location along the earth surface. अर्थ के surface से fixed spots है. जैसे ही उसके ऊपर से plates will move, what would happen? Eruption of lava will take place. It lead to formation of landforms like mountains, plateaus. These would be formed. So it may lead to formation of chains of mountains. Or if it is high explosive eruption, sometimes what may happen? It will lead to eruption of fissure type of eruption. So it will lead to formation of plateaus and plains. Best example, reunion hotspot से क्या create हुआ है? Deccan Plateau. I hope this is clear about mantle plumes. So what are hotspot volcanisms? Hotspot volcanism हो क्या रहा है? It is a type of volcanism basically which is occurring in interior parts of plates, lithospheric plates, but not at plate margins. Keep this thing in mind. It is not taking place at the plate margins, it is taking place in interior parts of the plates. Alright. But yeah, at plate margins also it may take place. Examples could be like Iceland hotspot, also a far hotspot. जो ईस्ट अफ्रीका में इमर्ज हो रहा है. So these are along the divergent boundaries. But mostly what is happening? This hotspot volcanism take place along the interior parts of the plates. All right. So best example. यहाँ पे होएगा diagram. So what is simply mantle plume? If you look at convection of abnormally hot rock within the mantle. Hot rock from the core mantle boundary it is rising. If you look at this diagram, core mantle boundary it is rising, and as it rises, it creates the plume shape. So this is mantle plume, and as it plume shape, what is happening? Plate is moving. As plate moves, this plate comes across the hotspot. So lava will come out and lead to formation of mountains or plateaus. All right. So mushroom shaped with the conduit connected head to base. Right. Now head expands as plume rises. So as mantle plume rises, it diverges. It creates tensional stress, creating tensional. So it is causing splitting of the lithospheric plate. Right now, lithospheric plate is intact. But this mantle plume which is rising, it will create cracks in the lithospheric plate, and these forces which are moving away from each other. These are tensions created. So plates will split, and through these gaps, magma will rise and create the landforms. Right. The Afar hotspot is the best example. So if you have to remember, just remember these few examples. Reunion hotspot, इसकी वजह से क्या create हुआ? Deccan Traps. Then Tristan hotspot, इससे क्या create हुआ? Parana Plateau in the South America. Then Galapagos, say Galapagos Plateau, right? Iceland create हुआ, Iceland hotspot से. Just keep these 2-3 in mind. Hawaiian Peninsula, Hawaiian mountains create हो रहे हैं. Alright. Just remember Reunion, Tristan, Iceland, Hawaiian. Alright. If you can remember Ontong Java also, it is created by Louisville hotspot say Ontong Java. That is it. These examples are enough. And yes, most famous one over here, Afar. It's not mentioned over here. Afar hotspot in the eastern part of Africa. Alright, these are the examples that you need to remember. I hope hotspot volcanism clear. So hotspots are at relatively fixed position. Their mantle is rising from, magma is rising from core mantle boundary. Right. All right. I hope this is clear. All right. Now comes the next topic, geysers. Next type of landforms which is created are geysers and hot water springs. Just need to remember few basic difference between geysers and hot water springs. See what is happening. This is rocks, or you can say this is water body. Right? Now we know water body is connected. Now in gaps of the rocks, what we find, some water will move downwards, and at the surface you have magma chamber. You can say like this. You have hot rocks, because rocks will get hot due to presence of the lava nearby. Now since this water will come in contact with the hot rocks, what would happen? Temperature of the water will increase. Now as temperature of water will increase, what would happen? All the water would be warm. Right. Now if there's a just presence of warm water body, that is known as hot water spring. But sometimes what happen, if you keep on boiling the water, you keep on increasing the temperature of the water, so there would be presence of gas bubbles inside the water. So what may happen in future, this warm water, it will explode and it will rise like a fountain. So this is known as geysers. In case of hot water spring, it's just you have a warm water body pool, which is in that case, what is happening? Water is connected to some hot rock, so which is providing continuous heat to that water body. That's why water is hot. But in case of geyser, what is happening? The temperature of water increases to that such extent that that water starts exploding. So it creates like a fountains. So that is geysers. Simple terms. So geysers form near active volcanoes. The best example, Iceland. Right? So water percolates in the porous rock subjected to heating due to contact with hot magma. So water at high pressure accumulated. Once pressure exceeds the threshold, what will happen? Steam would burst through fissures and fractures. And also it has silicate deposits in case of geysers. And those presence of silicate deposits gives the different colors. Simple. In case of hot water spring, color is due to cyanobacteria. Just keep these two facts in mind. Overhead silicate deposits, overhead color is due to cyanobacteria. That is it. Nothing else you need to know about this. Right? I hope this is clear. Geysers, hot water springs, these are basically landforms. Geyser, hot water springs, hotspot volcanisms, then various cones we have seen, and intrusive landforms. All right. Now comes, let's have a look at India part. In case of India, what we find, we have two kind of volcanic landforms. Now, if you have a basic idea, we'll see in the next class also. This is Himalayas. Himalayas is running like this. Right? Now, chain of Himalayas, if you look at, some part of Himalayas is submerged inside the water. And this leads to formation of what? These mountains, Andaman Nicobar Islands. Right? So over here you have two islands which have still signs of volcanic activity. Barren Island and Narcondam Island. So Barren Islands अभी क्या recently active हुआ है ये, right? So it is only active volcano in India. Right? इसको हम बोलते हैं basically it is in extinct state. Right? पर otherwise in the हम ये क्या बोलते हैं इंडिया में no active volcano in Himalayan region. We'll see the reason when we'll see the continent convergence. Right? Just keep this in mind. All right. इतना clear? So Barren Island, Narcondam Islands, ये clear होना चाहिए आपको इंडिया के केस में. इसके एग्जांपल्स एक्टिव क्या, एक्सटिंक्ट क्या. नाउ एक्टिव एक्सटिंक्ट, एक तो ये भी डिफरेंस पता होना चाहिए आपको. वोल्केनोस को हम डिवाइड करते हैं एक्टिव, डोरमेंट, एक्सटिंक्ट. ये टेक्निकल टर्म्स है. ये यूपीएससी ऐसे लिख देगी, इट इज एक्टिव वोल्केनो, इट इज डोरमेंट वोल्केनो. तो एक्टिव वोल्केनो कहते हैं इसमें इरप्शन क्या हो रही है, इरप्शन इज टेकिंग प्लेस फ्रीक्वेंटली. फ्रीक्वेंट इरप्शंस, राइट. इसमें कर रहे हैं नॉट फ्रीक्वेंट इरप्शंस. डोरमेंट मींस टेम्परेरी स्टेट पे है, टेम्परेरी सस्पेंशन हो रखी है. सो नॉट फ्रीक्वेंट इरप्शंस. ऑलराइट. एक्सटिंक्ट में क्या है, इरप्शन टुक प्लेस इन द हिस्टोरिक टाइम्स, बहुत सालों पहले. ऑलराइट. सो इंडिया का क्या है, बैरन आइलैंड एक्टिव है, नारकोंडम आइलैंड एक्सटिंक्ट है. एग्जांपल मिल गए. डोरमेंट के एग्जांपल अगर आपको चाहिए, सो डोरमेंट की है हाँ माउंट किलिमंजारो, कनाडा में है, सॉरी केन्या. राइट. देन इसका एग्जांपल माउंट किनी है एक्सटिंक्ट का. नारकंडम है, एक्टिव के तो इतने सारे एग्जांपल्स है, बैरन आइलैंड लिख लो एक, राइट। यूजुअली बैरन आइलैंड हम मानते थे कि एक्सटिंक्ट हो चुका है, पर अभी रिसेंटली 2017-18 में ये इरप्ट हुआ था, सो अगेन इट हैज बिकम एक्टिव। कीप दिस थिंग इन माइंड। ऑलराइट, then and also keep in mind this, क्या कहते हैं, यहाँ पे लैकेडिव आइलैंड्स है, लक्षद्वीप आइलैंड्स, जिसको हम लैकेडिव आइलैंड्स भी बोलते हैं। सो बेसिकली दे आर पार्ट ऑफ जो मिड ओशियानिक रिच है इंडियन ओशन में, विच इज नोन एज चागोस लैकेडिव रिच, दे आर पार्ट ऑफ दिस। इसके ऊपर बाद में कोरल्स डिपोजिशन हुई एंड इट बिकेम द कोरल आइलैंड्स, राइट। कीप दिस थिंग इन माइंड। All right, this is the basic that you need to know about these, about India. All right, now positives and negatives of the volcano. Okay, positives देखो, एक तो first of all it is creating new landforms, islands, volcanic mountains, plateaus, obviously we know about it. Economic wise क्या है, because igneous rocks आ रहे हैं, magmas आ रहे हैं, magma deposit हो रहे हैं, it is bringing minerals from the inside of the earth, so it is bringing various metallic ores, diamond, kimberlite rocks, right. Then also it is producing fertile soil, black soil, so it leads to formation of forest resources. Also it is producing thermal energy. If suppose we can connect, because we know hot rocks are present, so if we can tap that heat, how thermal energy is produced, I'll tell you. We know hot rocks are present, so what we will do, we will build a pipe, and through this pipe we will pass on the water. So what will happen, as water is moving, as water moves, it will absorb the heat of the hot rocks, and once now water absorbing heat, it will turn into steam, so there will be outside steam will come out from the another vent, so through that steam we will run the turbines and we can produce energy. So this is known as geothermal energy. Geo means earth, thermal means temperature, so we are using the heat of the earth to produce energy. So we have potential what in India, where there are two locations, Puga Valley in Ladakh, Manikaran in Himachal Pradesh. Keep these two places in mind. Over there we find the hot water springs also. Manikaran is famous for Sikh pilgrimage also. Right? Then it is bringing volcanic ash, black soil, which is quite popular for cotton in India. Right? Springs and geysers can be used for tourism. Yellowstone National Park, Mount Fuji. Social means loss of life, damage, and all those things. Tsunamis it causes, climatic. Now it releases a lot of gases. Volcanic ash is released, right? It may lead to temperature decline also and increase also. ये ध्यान रखना. Temperature increase भी कर सकता है, decline भी कर सकता है. Decline कैसे होएगा? If it releases lot of gases, so all the gases will cover the atmosphere, so it will block the entry of the sunlight. So if sunlight is not able to reach the earth surface, there would be transfer of heat, so temperature will decline. And how it may cause increase in temperature? Greenhouse gases are released, so greenhouse gases will trap the heat, so again counter radiation will happen, and that already heat on the surface of the earth, it remains trapped inside the earth's atmosphere. There won't be any escaping of the earth's heat, so this leads to increase in temperature also. So both may happen, right? Then it releases various type of materials. Pyroclastic debris, simply debris is small size. Volcanic bombs, again small size bombs. Ash and dust gases. All right, various gases are released: nitrogen gases, sulfur gases, chlorine, hydrogen, argon. These are the gases. And we know acid rain के लिए क्या चाहिए? Nitrogen oxides, and sulfur oxides. ये यूपीएससी ने डायरेक्टली पूछा भी हुआ है. How acid rain is formed? It is formed through sulfur oxides and this nitrogen oxides. ये ध्यान रखना. Alright. Any other? और तो कुछ नहीं है ना वोल्केनिज्म में. और कुछ है? यही है बेसिकली. गैसेस लिखने को लिख सकते हो. Which all gases are released because यूपीएससी पूछ चुका है. Environment में पूछता है usually. Which all gases are released? Hydro, because if you remember how formation of Earth's atmosphere took place, degassing phenomena, उसमें भी gases release हुई थी. Gases were released through volcanic activity only. So hydrochloric acid, these are released. Ammonium chloride, sulfur dioxide, carbon dioxide, CO2, right? Hydrogen, nitrogen, then hydrogen sulfide, then carbon monoxide. So these are the gases which are released, right? You have to remember these. And also there are few terms जो पता चाहिए. Fumaroles. Fumaroles, these are what? Nothing, gases plus dust combination. Then solfataras, when there is presence of sulfur. Fumaroles are also known as solfataras, provided they have presence of sulfur compounds. Right? These are the basics you need to remember because prelims में UPSC might ask you all about this. Right? You need to remember these things. Then you have, yeah, this is enough. Also, one more thing you can remember in order of volcanoes in terms of intensity of eruption. Basically, we classify various type of volcanoes into different categories in terms of their intensity. Okay, so in terms of intensity, what we have, most calm ones are Hawaiian type of eruptions. They are calm ones. All right. Then we have Strombolian type of eruptions. So over here intensity bit increases. Right. Then we have Vulcanian type of eruption. Again, intensity increases. You don't need to remember everything in detail about all this. Just in case UPSC may ask. Right. Then you have Plinian type of eruption. Right. Lastly, we have a Pelian eruption. So this is the order: Hawaiian, Strombolian, Vulcanian, Plinian, and Pelian. These are the few examples you need to remember. Right. This is the order of type of eruptions. So these are the worst type of maximum type of intensity. UPSC has never asked question on this, so I just cover the basics in case UPSC may ask. All right. So any doubt, please you may ask. I'll give you five minutes break. If anyone of you has any doubt, please to ask.
Hello, sir. Hello, sir.
Hello, हाँ जी.
Yes, sir. एक वो टर्म भी होता है
Yes, please.
क्रिएटर. यस सर. क्रिएटर के अलावा क्रिएटर कार्डेरा और उसके सेंडर के अलावा एक कार्डिलेरा भी होता
Hello.
है. कार्डिलेरा. हेलो.
Hello.
हेलो.
I'm not able to hear you properly.
हेलो.
I'm not able to hear you. Can you please type it again?
She's talking. Hello.
ओके ओके सर.
Caldera. Excuse me,
कार्डिलेरा.
sir. Excuse me, sir. Can you hear me? Hello. Hello.
यस यस सर. आई कैन हियर.
I'm talking about Caldera, na? I think
यस
please.
कार्डिलेरा.
Caldera is there.
Okay.
Yes.
Okay, you have an issue with Caldera. Okay, what else?
No, sir, I don't have an issue, but I have said that creator कार्डिलेरा and वो सिंडर के अलावा एक और टर्म भी है कार्डिलेरा जो
Cardilera.
यस जो कि वोल्केनिक माउंटेन्स की चेन होती है उसको बोलते हैं कार्डिलेरा.
Okay, okay, that is a different thing. Cordillera. Yeah, got it. वो different चीज है. Yes. वो मतलब when we'll cover the plate tectonics topic, during that topic it will get covered.
Okay, and in my notes it is written that cinder cones are formed due to deposition of ash and broken rock material, and yeah, these
yes,
are
yes.
weak cones.
Yes. These are long depressions. See how volcanic cones are formed. Volcanic cones are formed by deposition of uh, ashes, dust, and lava. So these only volcanic cones are formed.
Yeah, sir.
So this is what your notes are saying. Right? Any other doubt?
And कोल्डेरा के लिए ये लिखा हुआ है सर, लार्ज फॉर्म ऑफ क्रेटर इज नोन एज कोल्डेरा.
Yes, same only. That's why I said they are same. It's just their way of formation is different. That is it. It's just
Yes.
craters. You have crater cones, cinder cones. If their size increases, they are known as caldera cones.
Okay,
It's
sir.
just their way of formation is different. Yeah.
Okay. And sir, can I ask about
Any other doubt?
होट्स जो सन स्पोर्ट्स होते हैं उसमें यू हैव सेड दैट कि जो लाइट है उसकी वजह से वो अर्थ पे कुछ दिक्कतें आती है, ला लेना वगैरह. यू कैन एक्सप्लेन दैट पार्ट.
Yes.
जो मतलब कि सन स्पोर्ट की वजह से.
El Nino part.
हाँ, नहीं मतलब जो सन स्पोर्ट जो ठंडे रीजन
what is
हो
happening?
जाते हैं,
Sunspots
थोड़ा
are the
टेम्परेचर डिक्रीज होता है उसका,
yes.
उसकी वजह से ला नीना में वो
See, I will tell
जो
you.
इफेक्ट पड़ता है.
See, right now, You just need to know about sun. It has some suns. Sun.
Excuse me, आवाज नहीं आ रही सर.
हाँ, ये कुछ टेक्निकल इशू हो गया था. अब आई होप नाउ am I audible?
Yes, yes.
Yes, sir. Yes, sir. Audible.
I guess there was some technical issue. All right. What I was saying, see, on the sun, we have some dark spots, which are known as sunspots, right? So because of this, what happens? This increase in intensity of these solar winds. And these sunspots usually occur after every 11-year cycle. But now, due to climate change and all, due to other factors, the cycle is getting reduced, intensity or duration of the cycle. All right. So because of this, what happens? Increase in solar winds intensity, now increase in presence of more solar winds on the Earth's surface. So it increases the temperature. So we'll see in detail like how it causes El Nino phenomena and how it causes La Nina phenomena. Basically, it is associated with the Eastern Pacific Ocean.
हेलो
So
हेलो
when will yes,
हाँ सर, ये तो ओके, लालिना आगे तो टेम्परेचर इंक्रीज की वजह से समझ हो गया, बट ये समझना था मेरे को कि सनस्पॉट की वजह से ये जो सोलर विंड्स है ये क्यों ज्यादा आती है, इंक्रीज क्यों होती है ये, क्योंकि सनस्पॉट तो ठंडे रीजन्स होते हैं ना जो आसपास का एरिया, उससे
उसके उसके लिए हम आदित्य L1 भेजा अभी हमने. वो जब आंसर आ जाएगा तो बता देंगे. मतलब see, like what is our conclusion is what we have assumed. Suppose if we cool something down, what is happening? Like suppose you have heated the pan. Now you just suddenly cool it down. What would happen? Huge amount of heat is released from that pan, right? If you heat एक एक pan को heat करो और एकदम से उसको cool down कर दो, आप एक ठंडे पानी में रख दो, तो एकदम से heat release होती है, huge amount of heat is released. तो ये
यस
assume कर रहे हैं.
आई गेट इट,
हाँ.
मतलब
तो
ठंडा
बस
रीजन
ये
हो
हम
सकता है।
तो बस यही एक लॉजिक है बस जो हमें पता है, ये हमने assume किया. Now how exactly all this process is taking place? That's why we have launched Aditya L1 satellite. Even NASA has sent many satellites. Even Japan, China, all these. So हम explore कर रहे हैं कि exactly है हो क्या रहा है sun पे. Because we have not been able, हमारा कोई device reach नहीं कर पाया वहाँ पे. We humans can hardly go over there sun to the near the sun. So we have just assumed कि ऐसे dark spots हो रहे हैं, उससे more heat is released. That is it.
यस यस सर, ओके ओके, आई विल।
This is the basic thing. All right. Clear? Any other doubt to anyone? Any other doubt?
No, no, sir. Thank you.
Okay. Can I resume?
Yes.
All right. So, all right. So, volcanoes topic is done. Now, so we have already covered chapter 1, basics of the these geomorphology. Then we covered this topic of interior of the earth. In the interior of the earth, we have seen sources, earthquake topic done, volcano topic done properly. So our next topic is distribution of oceans and continents, right? So now our distribution of ocean continents, it is also favorite topic of UPSC for means purpose. प्रीलिम्स में हार्डली क्वेश्चन आए इसमें. जो अभी जो टॉपिक्स रहेंगे ना, नेक्स्ट फ्यू टॉपिक्स ऑफ जियोमॉर्फोलॉजी, नेक्स्ट टॉपिक्स क्या क्या है? एक तो डिस्ट्रीब्यूशन ऑफ ओशंस एंड कॉन्टिनेंट्स, ये भी मीन्स का टॉपिक है, पर चलो हमें वी हैव टू स्टडी इट वंस. देन उसके बाद आते हैं जियोमॉर्फिक प्रोसेसेस. We talk about these what do you say, geomorphic processes, endogenetic and exogenetic forces. So basically we'll be talking about weathering, mass movement and erosions. Then lastly we'll have erosion, various landforms, erosional and depositional. Also we have one topic of rocks. Right? So if you look at over here, this is means topic. From this region, UPC has hardly asked any question. Even in prelims means UPC had never asked question on this, but still we have to cover it. But this will never be our priority. Just keep this in mind. We will understand the basics of these topics, but this won't be our priority because UPSC had never asked question on this, because this is a bit complex topic and UPSC always asks question on this in optional, geography optional, but not in the GS part. Then rocks part, last year it had asked question in means what are primary rocks and types of primary rocks. And in prelims also it may ask because rocks involves minerals and mineral sources is the favorite topic of UPSC. So this is how our next few topics would be in case of geomorphology. But yes, we do have to study them, get a basic understanding. In case UPSC asks questions from this region, we should be prepared. Okay. So first of all, we need to have a basic idea how questions UPSC had asked question or not. Now we have got an idea. UPSC had not been asking question on these areas. All right. So now let's start studying. All right. So that's why I've not prepared any notes, specific notes for it. Reading NCERT would be sufficient. All right. First of all, facts. If you look at, we know continents, how Earth is divided. Continents and oceans. This is how Earth is divided. Continents share is 29% and ocean share is 71%. Keep this in mind. This is Earth. So 71% of Earth is ocean. That's why it is known as blue planet. So continents cover 29% of the surface of the Earth. Remainder is under oceanic waters. Okay. Now question rises. In today's time, we see a map of world. So we see the position of the continents. So the position of the continents, was it same in the past also, or that position of the continents like we have world map like this? I hope you all know how to draw a map. I will share the video on this. मुझे याद करा देना, मैंने एक्चुअली रिकॉर्ड किया था एक how to draw world map and Indian map. So I will share it with you all. Alright. ये उसको YouTube पे डाल देंगे. Alright. So this is the position of the present distribution of oceans and continents in today's time. So now if you look at this, Was this distribution of ocean content same in the past or not? But it was not, as we have found through various studies, right? Keep this in mind. It was not. And in the future also, neither in the past it was the same, present is like this. In the future also, it won't be the same. It would be changing. Keep this basic thing in mind. To explain this, various theories have been given. Alright. First of all, Abraham Ortelius, he said कि यूरोप एंड अफ्रीका को अगर हम ज्वाइन करते so it will create a one large landmass. So this idea was supported by Antonio Pellegrini also. Alright. So so now came Alfred Wegener. I'll give you the crux of his theory. First of all, I'll give you the crux of all the theories. Then we can start with the explanation part. Now see, ये various theories है. First of all, your objective should be clear. इन theories का objective क्या है? That can be used as an introduction for a mains answer also. So all these theories tries to explain distribution of oceans and continents. कि आज के time पे how ocean and continents are distributed, or how they were in the past, how they were in the future. So this is the main objective theme. First of all, you need to be clear about these things. Now, so various theories have been given. First theory was continental drift theory by Alfred Wegener. Then came convection current theory by Arthur Holmes. Then seafloor spreading by Harry Hess. You don't need to remember the names, but still एक दो याद कर लेना. Plate tectonics Morgan ने दी थी, right? So these are theories that we have to study, and this is the present times most acceptable theory. All right. So let's have a look at CDT. And now he wants to explain the present distribution of ocean continents. So what it says in the past there was a large landmass, Pangaea, surrounded by the Panthalassa. This was the Earth, right? It got split into two halves, Laurasia, Gondwanaland, separated by Tethys Sea. Further, it got separated and present distribution. So Laurasia got broken up into North America, Europe and Asia. Gondwanaland broke up into South America. These are the countries: South America, Africa, Antarctica, Australia. Then यहाँ पे Madagascar, even peninsular India. So these were the part of Gondwanaland. Laurasia के कौन-कौन से? North America, South America, Asia का. ये ध्यान रखना. So present distribution of, right? So this is how this was his theory. कि 200 ये split कब हुए? During Mesozoic period. या 200 million years ago. उसने कहा कि Pangaea Panthalassa का split हुआ, present distribution बना. ये इसकी theory थी. और इसने क्या बोला? It's the continents that are moving. Continents drift. और forces अब move कैसे कर रहे हैं? Two forces कहा था इसने, pole fleeing force and tidal force. Tidal force is due to gravitational force, the gravitational pull of Earth and Moon, and pole fleeing force is due to rotation of the Earth. Be clear. Pole fleeing force, that means this is pole. So due to rotation of the Earth, every object is escaping the poles. So they're moving towards the equator. So this is pole fleeing force. All right. So in order to prove this, he gave few evidences. Evidences क्या क्या दिया इसने? पहला दिया geographical evidence. That means jigsaw fit. Jigsaw fit इसने किस किस को किया? अफ्रीका एंड साउथ अमेरिकन कोस्ट को. अगर आप देखो ये वाला एच साउथ अमेरिका का, ये नॉर्थ अमेरिका इस वाले एच को ओवरलैप कर सकता है. सो इसने ये एग्जांपल दिया कि जिक्सॉ फिट हो रही है. ऑलराइट. पर एक्चुअल का कहां पे होती है ये फिट? 1000 फैथम लाइन पे, जो हमें प्रेजेंट बाउंड्री दिख रही है उस पे नहीं होएगा, रादर 1000 फैथम लाइन की डेप्थ पे होएगा। फैथम जैसे हम किलोमीटर बोलते हैं, ऐसे फैथम एक टर्म है। और सेकेंड एविडेंस क्या दिया इसने, जियोलॉजिकल रॉक्स का। तो इसने देखा कि अगर ये पहले जुड़े हुए थे, कोई अगर एक एरिया है, ये पहले ज्वाइंट थे, तो जो रॉक्स यहाँ पे मिल रहे हैं वही सेम रॉक्स यहाँ मिलेंगे। अगर चाहे सेपरेट भी हो जाए, स्टिल रॉक्स तो सेम ही रहेंगे। बीच में सेपरेट होके ऐसे होके वाटर आ गया, पर रॉक्स तो सेम ही है। तो दैट मीन्स अगर रॉक्स सेम मिल रहे किसी एरिया पे, दैट इज पॉसिबिलिटी है they were joined in the past. So rocks of same age across the oceans. ये उसने एग्जांपल दिया, राइट। देन it talked about, इसने एनिमल्स का भी दिया, फॉसिल्स का एग्जांपल। अब देखो प्लांट्स है, प्लांट्स तो मूव नहीं कर सकते, और एक ही रीजन पे एक टाइप ऑफ प्लांट्स मिलेंगे, तो एक रीजन में आपको दो प्लांट्स मिल रहे हैं और ये बाद में सेपरेट हो गए, और अब के उनके बीच में वाटर बॉडी है, पर हो सकता है पास में जुड़े होंगे तभी सेम काइंड ऑफ प्लांट आपको दो जगह मिल रहे हैं, अदरवाइज पॉसिबिलिटी नहीं है, डाइवर्सिटी इतनी रहती है। सेम इज केस ऑफ एनिमल्स, जो फ्रेश वाटर एनिमल्स है, अब वो तो ओशन से ट्रैवल करके नहीं जा सकते बिकॉज ओशन में सैलिनिटी है, तो फ्रेश सेम काइंड ऑफ फ्रेश वाटर आपको दो उसके क्रॉस मिल रहा है, ओशन के क्रॉस, तो कैसे पॉसिबल है ये। सो दिस वाज हिज थर्ड एविडेंस जो उसने दिया था। फोर्थ एविडेंस उसने क्या दिया, टिलाइट्स का, सेम काइंड ऑफ सेडिमेंटरी डिपोजिशन बाय ग्लेशियर्स। ये उसने एग्जांपल दिया कि एक ही रीजन में आपको सेम काइंड ऑफ सेडिमेंट्स डिपॉजिट कर रहे ग्लेशियर, तो मतलब वो सारे एरियाज ग्लेशियर ग्लेशिएशन से एक्सपीरियंस कर रहे थे, और जो सेडिमेंट्स डिपॉजिट हुए उसे बोलते हैं टिलाइट्स, तो वो भी वो एज एविडेंस यूज किया, राइट। सो लेट्स हैव अ लुक एट द थ्योरी। सो व्हाट इट सेड, इट इज रिगार्डिंग द डिस्ट्रीब्यूशन ऑफ ओशन कॉन्टिनेंट्स। 1912 में आई थी, Pangaea was there surrounded by Panthalassa around 200 million years ago or Mesozoic era. So Pangaea got broke up into two landmass, Laurasia and Gondwana land, and further it broke up into various smaller continents जो आज exist करते हैं। Simple theory, evidence, matching of the continents, jigsaw fit. So अफ्रीका एंड साउथ अमेरिका की जिक्सॉ फिट किया, पर एक्चुअल हमें कहाँ मिलता है 1000 फैथम लाइन पे इंस्टेड ऑफ प्रेजेंट शोर लाइन, ये ध्यान रखना। रॉक्स ऑफ सेम एज अक्रॉस द ओशन, इसका एग्जांपल क्या दिया इसने एग्जांपल दिया ब्राजील कोस्ट, सॉरी ब्राजील कोस्ट along with the western Africa. तो यहाँ पे जो rocks मिल रहे हैं they are of the same type, right? They all belong to Jurassic age, right? और ये क्या सजेस्ट करते हैं कि पहले अफ्रीका और साउथ अमेरिका के बीच में कोई ओशन भी नहीं था, ये भी लिख सकते हैं। टिलाइट डिपॉजिट्स, टिलाइट के बेसिकली जो ग्लेशियर्स डिपॉजिट करते हैं सेडिमेंट्स, ग्लेशियर्स मूव कर रहे हैं, सेडिमेंट्स इकट्ठा अपने साथ लेके चल रहे हैं, और जब वो मेल्ट होना स्टार्ट होंगे तो अपने डिपॉजिट्स को डिपॉजिट, वो सेडिमेंट्स नीचे गिर जाएंगे सरफेस पे, उसे डिपॉजिट्स बोलते हैं। तो डिपॉजिट्स डिपोजिशन बाय ग्लेशियर्स, दे आर नोन एज टिलाइट्स, ध्यान रखना। ऑलराइट, तो हमें जो टिलाइट्स मिले ये मिली हमें गोंडवाना लैंड, जो लोडेशिया और गोंडवाना में सेपरेट हुआ था। तो गोंडवाना लैंड के जितने एरियाज थे, साउथ अमेरिका, अफ्रीका, मेडागास्कर, इंडिया, ऑस्ट्रेलिया, अंटार्कटिका, इन ऑल 6 रीजन्स में हमें टिलाइट्स मिलते हैं, 6 डिफरेंट लैंड मासेस। तो साउथ अमेरिका का है फॉकलैंड आइलैंड, अब ये लोकेशन याद कर लो, न्यूज़ में भी था फॉकलैंड आइलैंड। फॉकलैंड आइलैंड का है यहाँ पे है। ये क्या है फॉकलैंड आइलैंड, ये एक्चुअली न्यूज़ में था अभी रिसेंटली। फॉकलैंड आइलैंड में क्या है, एक इट इज अंडर द इंग्लैंड, और यहाँ पे अभी एक कॉन्फ्रेंस हेल्ड हुई थी जहाँ पे इंडिया और अर्जेंटीना ने मिलके इंग्लैंड के साथ कॉन्फ्रेंस की थी। तो फॉकलैंड आइलैंड इंपॉर्टेंट है। याद करो फॉकलैंड करंट, ओशन करंट्स में कोल्ड ओशन करंट। और तो कौन कौन सी रीजन है? अफ्रीका, फॉकलैंड आइलैंड, मेडागास्कर, अंटार्कटिका, ऑस्ट्रेलिया। राइट, इंडिया तो है ही ऑफ कोर्स। तो यहाँ पे हमें टिलाइट डिपॉजिट्स मिलते हैं। तो ये क्या शो कर रहा है कि अगर आपको एक ही रीजन में, मतलब अभी ये सारी रीजन दूर दूर है, तो अगर आपको एक ही सेडिमेंट्स इन सभी रीजन में मिल रहे हैं तो हो सकता है पहले ही जुड़े हुए थे, अभी ड्रिफ्ट हुए हैं। और क्या शो कर रहा है? पास्ट का क्लाइमेट कैसा था। अगर ग्लेशियर तो पास्ट शो कर रहा है, पेलियो क्लाइमेट मींस क्लाइमेट ऑफ द पास्ट। तो पास्ट का क्लाइमेट क्या था? ग्लेशिएशन। ये भी शो कर रहा है एविडेंस, राइट। देन प्लेसर डिपॉजिट्स, हाँ प्लेसर डिपॉजिट्स भी आएगा। और प्लेसर डिपॉजिट्स क्या है? देखो सिंपली, अगर रिवर है, रॉक्स को इरोड करेगी, सेडिमेंट्स कैरी करेगी एंड इट विल डिपॉजिट इनटू एट दी, जहाँ पे बेस लेवल यू कैन से, जहाँ पे वेलोसिटी ऑफ द वाटर डिक्रीजेस, और यू कैन से नियर द डेल्टा रीजन, वहाँ पे डिपोजिशन करेगी सेडिमेंट्स को, राइट। सो जो मिनरल्स इसने इरोड किया रॉक से, तो वाटर उनको कैरी कर रहा है, रिवर वाटर, और डिपॉजिट कर रहा है डेल्टा में। तो ऐसी डिपॉजिट्स को बोलते हैं प्लेसर डिपॉजिट्स। So these are the deposits which are deposited near the source of mouth of the river, right? So basically rocks are eroded, minerals are added into water, those minerals are transported and deposited by the river to some other location. These are known as placer deposits. तो ये minerals का source क्या है? source तो यहाँ पे rock, पर ये deposit का हो रहा है कहीं और location पे। तो ऐसे ही हमें क्या मिला है घाना और ब्राजील के केस पे। जो गाना वाले रीजन है वहां पे हमें प्लेसर डिपॉजिट्स मिल रहे हैं गोल्ड के, पर जो रिवर का सोर्स है वो हमें कहाँ मिल रहा है? ब्राजील में। तो ये कैसे पॉसिबल है कि पास्ट में जुड़े होंगे तभी सेपरेट हुए हैं, राइट। सो प्लेसर डिपॉजिट्स का ये एग्जांपल हमने यूज किया एज ए एविडेंस, जो अल्फ्रेड वेगनर ने दिया। सो प्लेसर डिपॉजिट्स ऑफ गोल्ड इन घाना कोस्ट, पर एब्सेंस ऑफ सोर्स रॉक। सोर्स रॉक कहाँ मिला हमें? ब्राजील में। देन डिस्ट्रीब्यूशन ऑफ फॉसिल्स, right? Identical species of plants and animals found on either side of the marine barriers. तो basic example लेमुर्स। लेमुर्स कहाँ मिल रहा है? इंडिया, मेडागास्कर, अफ्रीका। लेमुरिया बोलते हैं इन तीनों को। इंडिया, अफ्रीका, मेडागास्कर, ये तीनों गोंडवाना लैंड के पार्ट थे। इन्हें हम क्या बोलते हैं? लेमुर, लेमुरिया। तो लेमुर्स मिलते हैं हमें, ऑर्गेनिज्म होते हैं, राइट। ऐसे ही हमें कहाँ मिल रहा है? मेसोसॉरस। ऐसी साउथ अमेरिका और अफ्रीका, यहाँ पे हमें क्या मिल रहा है? मेसोसॉरस। अब मेसोसॉरस क्या है? फ्रेश वाटर रेप्टाइल है। नाउ दे कैन ट्रैवल थ्रू मरीन वाटर, क्योंकि ब्रैकिश होएगा, सैलिनिटी होगी। सो हाउ इज इट पॉसिबल? फ्रेश वाटर ऑर्गेनिज्म फाउंड अक्रॉस द ओशन। तो ये पहले जुड़े होंगे, और कहाँ कहाँ मिल रहे हैं? सर्दर्न केप प्रोविंस ऑफ साउथ अफ्रीका एंड इरावर इरावर फॉर्मेशन इन ब्राजील। ये ध्यान रखना, इरावर फॉर्मेशन साउथ अफ्रीका, साउथ सर्दर्न केप। जस्ट रिमेंबर दिस। तो दो कीवर्ड्स है, लेमूर्स, लेमुरिया, and these Mesosaurus and South Africa, right? Alright, forces क्या यूज किया उसने? pole fleeing force. Pole fleeing force is related to the rotation of the earth, right? Tidal force is attraction of the moon, but these forces are inadequate, so that's why they have not been acceptable. ये क्लियर? किसी को कोई डाउट? आई गेस आज इतना ही हो पाएगा, है ना? नो वरीज, मतलब अब तो हो जाएगा जल्दी। convection current theory, seafloor spreading, plate tectonics, then we'll having various topics, वो geomorphic process, weathering and all. Max to max 2 more sessions will take to complete this geomorphology. Alright.